Oklahoma, located in the heart of the United States, is a state rich in history, natural beauty, and diverse landscapes. Spanning over 180,000 square kilometers, Oklahoma is home to rolling plains, ancient mountain ranges, vast forests, and some of the most unique geological formations in the country. From its towering red rock canyons to its expansive prairies, Oklahoma is a land filled with hidden wonders that continue to intrigue and inspire. Have you ever wondered just how much of Oklahoma remains undiscovered, waiting to be explored? Imagine the ancient mountains, deep caves, and windswept plains holding untold mysteries, some so ancient and fascinating that they may change how we understand this central state. From its rugged wilderness to its mysterious underground formations, Oklahoma's landscapes hold stories of the past, untapped resources, and wildlife that thrive in some of the state's most remote areas. Oklahoma is a land of pioneering spirit, natural wonders, and new discoveries that captivate adventurers and scientists alike. Join us on an epic journey across Oklahoma's unknown frontiers, where every discovery reveals more about the land's rich history and intriguing present. Prepare to be amazed and perhaps a little surprised as we explore one of the country's most fascinating natural frontiers. Let's dive into the wonders of Oklahoma's hidden wilderness. The ancient mountains, the Ouachitas, and the Arbuckles. Oklahoma is home to some of the oldest mountain ranges in North America, including the Ouachita Mountains in the southeastern part of the state and the Arbuckle Mountains in the south-central region. These ancient mountains have been shaped by millions of years of erosion, creating rugged peaks, valleys, and deep canyons. The Ouachita National Forest offers a landscape that feels untouched by time, with dense forests, scenic rivers, and hidden waterfalls. The Arbuckle Mountains, on the other hand, are famous for their unique geological features, including Turner Falls, the state's tallest waterfall, and Honey Creek Cave, one of Oklahoma's largest cave systems. What other geological wonders lie hidden in these ancient mountains, waiting to be discovered? The Wichita Mountains, Oklahoma's granite giants. One of Oklahoma's most stunning natural features is the Wichita Mountains in the southwestern part of the state. These rugged granite peaks, some of the oldest in the world, rise dramatically from the surrounding plains and offer breathtaking views of the landscape. The Wichita Mountains Wildlife Refuge is home to diverse wildlife, including bison, elk, and longhorn cattle, and is a haven for nature lovers and outdoor adventurers. The Wichitas are also a favorite spot for rock climbers, hikers, and geologists due to their unique formations. The mountains have a rich history, once considered sacred by Native American tribes, and contain ancient sites that are still being explored today. What hidden stories and natural wonders could the Wichita Mountains still hold? Oklahoma's hidden caves, subterranean secrets. Beneath Oklahoma's rolling hills and rugged mountains lie extensive cave systems that remain largely unexplored. The Alabaster Caverns State Park, located in northwestern Oklahoma, is home to one of the largest natural gypsum caves in the world, with stunning formations of alabaster and rare crystal structures. The state's caves, such as Collings Cave and Jester Cave, hold secrets of the past, including fossilized remains of prehistoric creatures and evidence of early Native American activity. These caves offer a glimpse into Oklahoma's distant past, but many are still unexplored. What other ancient secrets could be hidden beneath the surface of Oklahoma's wilderness? The mysterious red beds and fossil discoveries. Oklahoma's red beds are a geological marvel, a vast region of vivid red sandstone and shale formations that stretch across the central and western parts of the state. These iconic red rocks, visible in cliffs, buttes, and mesas, were formed over 250 million years ago during the Permian period, a time when the region was dominated by arid deserts and shallow inland seas. The iron oxide content in the rock layers is what gives the red beds their striking reddish hue, which is both visually stunning and geologically significant. The red beds are not only a testament to ancient environmental conditions, but also a rich repository of fossils, providing crucial insights into the life forms that existed long before the age of dinosaurs. These rocks hold the preserved remains of creatures that lived during the Permian and Triassic periods, times of dramatic evolutionary change. The fossils found in the red beds tell the story of an era when reptiles, amphibians, and early proto-mammals ruled the land, offering paleontologists a window into the distant past. Geological significance of the red beds. The Permian red beds of Oklahoma are part of a broader geological formation that extends across much of the American Southwest. These rock layers were deposited during a time when the supercontinent Pangaea was still intact, and the region that is now Oklahoma was part of a vast inland desert. The alternating layers of sandstone, shale, and mudstone represent cycles of deposition in an environment that fluctuated between dry desert conditions and shallow seas, leaving behind a rich stratigraphic record of ancient climates. In addition to the iron oxide that gives the red beds their color, these layers also contain gypsum, halite, and other evaporate minerals, which were deposited as water from the inland seas evaporated. These minerals, along with the fossilized remains of the creatures that once inhabited the region, make the red beds an area of immense interest for geologists and paleontologists alike. By studying the rock layers and the fossils they contain, scientists can reconstruct ancient ecosystems and better understand how life adapted to the extreme conditions of the Permian and Triassic periods. Fossil discoveries, a window into prehistoric life. The red beds of Oklahoma have yielded some of the most significant fossil discoveries in North America, offering a glimpse into the Permian extinction, which wiped out about 90% of Earth's species, as well as the dawn of the age of dinosaurs. Some of the earliest known fossils of mammal-like reptiles, known as synapsids, have been discovered in the red beds, along with early amphibians and reptiles that dominated the landscape during the Permian and Triassic periods. One of the most famous fossils found in Oklahoma's red beds is that of Dimetrodon, a predatory synapsid that lived around 295 million years ago. Although often mistaken for a dinosaur, Dimetrodon actually predates the dinosaurs by millions of years and is more closely related to mammals. This creature, with its iconic sail-like structure along its back, was an apex predator of its time, and its fossils have provided valuable information about the evolution of vertebrates during the Permian period. Other notable discoveries include Archaeops, a large amphibian with a broad, flat skull, and Edaphosaurus, a herbivorous synapsid that also had a sail-like structure on its back. These creatures lived in an ecosystem dominated by swamps, rivers, and seasonal floodplains, much different from the arid deserts that would later characterize the region during the Permian. In more recent years, paleontologists working in the red beds have unearthed fossils of early dinosaurs and their close relatives, suggesting that Oklahoma was home to some of the first dinosaurs to appear on Earth. Fossils of theropods, sauropods, and ornithischians have been found in the region, providing evidence that the red beds were a critical environment for the evolution of early dinosaurs during the Triassic period, over 230 million years ago. Paleontological potential, unexplored and untapped. Despite the numerous discoveries already made, the vast majority of the red beds remain unexplored. This leaves open the exciting possibility that new fossils, perhaps of previously unknown species, are still waiting to be discovered. Paleontologists believe that the red beds could hold the remains of not only dinosaurs and reptiles, but also the ancestors of modern mammals, birds, and other vertebrates. As climate and environmental conditions continued to shift through the Triassic and into the Jurassic period, the red beds may contain fossils that document these evolutionary transitions in greater detail. In addition to vertebrate fossils, the red beds are also rich in plant fossils, including the remains of ancient ferns, conifers, and other vegetation that dominated the landscape during the Permian and Triassic periods. These plant fossils are crucial for understanding the paleoecology of the region, helping scientists reconstruct the ancient environments in which the animals lived, and providing insights into how ecosystems responded to climatic changes and mass extinction events. Given the vastness of the red beds and the relatively small number of paleontologists working in the region, much of the fossil-rich terrain remains untapped. Advances in technology such as ground-penetrating radar, LiDAR, and drone surveys are beginning to open up new possibilities for exploration, allowing researchers to map the region more effectively and identify potential fossil sites that were previously inaccessible. These tools could lead to the discovery of new fossil beds and shed light on critical periods in Earth's history, such as the Permian-Triassic extinction event and the rise of the dinosaurs. A fossil hunter's paradise. For amateur fossil hunters and geology enthusiasts, Oklahoma's red beds are a veritable treasure trove of ancient relics. Some areas of the red beds, such as the Cimarron County in the Panhandle, are open to public fossil hunting, where enthusiasts can search for fossilized footprints, bones, and plant imprints. These areas are a popular destination for both professionals and hobbyists looking to make their own discoveries, adding to the allure and mystery of the region. Fossil enthusiasts may find trace fossils, such as footprints, burrows, and coprolites, fossilized dung, which provide important clues about the behavior and environment of prehistoric creatures. Trace fossils can often reveal more about how these animals lived than bones alone, offering insights into their movement, feeding habits, and interactions with their surroundings. Future discoveries in the red beds. As exploration of the red beds continues, the possibility of uncovering new species and untold secrets from Earth's distant past remains high. Paleontologists are optimistic that ongoing research and exploration in this region will not only fill in gaps in the fossil record, but also provide answers to critical questions about the evolution of life on Earth, particularly during periods of mass extinction and recovery. The red bed's combination of geological beauty and paleontological significance makes them one of Oklahoma's most important natural resources. They are a reminder of the ancient history that lies just beneath the surface, waiting to be unearthed and understood by future generations of scientists, adventurers, and enthusiasts. Pause for a moment if you're enjoying this journey through Oklahoma's hidden landscapes. Don't forget to subscribe and hit the notification bell to stay updated on more incredible explorations. Recent geological discovery: Oklahoma's increasing earthquake activity. In recent years, Oklahoma has experienced an unprecedented surge in earthquake activity, a stark contrast to its once stable seismic history. Traditionally, Oklahoma recorded few earthquakes, typically less than 2 earthquakes of magnitude 3.0 or higher annually before 2009. However, by 2015, the number of such earthquakes skyrocketed to nearly 900 in a single year, alarming scientists and residents alike. The epicenter of this phenomenon is primarily located in areas with significant oil and gas production, particularly in the central and northern parts of the state. Studies have increasingly attributed this seismic uptick to wastewater injection practices. During oil extraction, large quantities of water mixed with chemicals and sediments, referred to as produced water, are brought to the surface. To dispose of this wastewater, it is injected deep underground into porous rock formations, far below the water table. However, this process has unintended consequences. By increasing pore pressure within these deep rock layers, the injected water can cause dormant faults to slip, triggering earthquakes. Oklahoma's geology is crisscrossed by fault lines, many of which are now believed to be more sensitive to these pressure changes than previously thought. One of the most striking examples of this induced seismicity occurred in September 2016, when a magnitude 5.8 earthquake hit near Pawnee, marking the strongest earthquake in Oklahoma's recorded history. The event caused structural damage to buildings, particularly older structures not built to withstand earthquakes. Smaller tremors also occurred in the days and weeks following the major event, further increasing concern about the potential risks. This increase in seismic activity has prompted researchers to delve deeper into the correlation between wastewater injection and earthquakes. In 2015, studies from the U.S. Geological Survey, USGS, confirmed that wastewater disposal was the likely cause of many of these quakes. As a result, state regulators, specifically the Oklahoma Corporation Commission, OCC, introduced new rules aimed at limiting the volumes of injected wastewater. These regulations mandated the reduction of injection volumes in high-risk areas, and in some cases, the closure of specific injection wells near known fault lines. The new regulations have led to a significant reduction in earthquake frequency. By 2018, the number of earthquakes of magnitude 3.0 or greater had decreased to just over 200, a notable improvement, though still much higher than pre-2009 levels. However, researchers caution that reducing injection alone might not fully eliminate the earthquake threat, as subsurface pressures can take years to stabilize, meaning quakes could continue even after injections cease. This discovery has not only impacted regulations, but also deepened scientists' understanding of how human activities can trigger seismic events. The concept of induced seismicity, where human actions such as mining, dam construction, and fluid injection cause earthquakes, has now become a critical field of study. Oklahoma's experience is shaping policies worldwide, with other regions involved in oil and gas production taking note of the lessons learned. As scientists continue to monitor Oklahoma's seismicity, they are also investigating whether certain geological features or fault lines are more prone to human-induced earthquakes. Advances in seismic mapping technology and ground-penetrating radar are helping to identify hidden fault lines that could pose future risks. Moreover, researchers are exploring whether alternative disposal methods for wastewater, such as surface treatment or recycling, could mitigate the seismic threat while allowing oil and gas operations to continue. Looking ahead, scientists are also considering how climate change could play a role in exacerbating seismic risks. With changing weather patterns, increased rainfall, and other environmental shifts, pressure within the Earth's crust may fluctuate further, potentially interacting with injection practices in unforeseen ways. In conclusion, Oklahoma's increase in earthquake activity has shed light on the significant role human activity can play in geological processes. The ongoing research and regulations introduced have provided critical insights that could help mitigate risks, not only in Oklahoma, but in other regions globally facing similar challenges due to oil and gas production. Tornado Alley, the heart of extreme weather. Oklahoma is located in the heart of Tornado Alley, an area known for some of the most extreme and violent weather in the world. The state experiences more tornadoes per square mile than almost anywhere else on the planet, making it a hub for meteorologists studying these powerful storms. From the destructive tornadoes that have shaped the state's history to the advances in storm prediction and safety, Oklahoma's relationship with extreme weather is both a source of concern and fascination. How do these storms impact the state's natural environment and its wildlife? As climate change continues to influence weather patterns, what will the future hold for Oklahoma's already turbulent climate? The Great Plains, Oklahoma's wild frontier. The Great Plains of Oklahoma, stretching across the western part of the state, are home to vast expanses of grasslands, rolling hills, and unique rock formations. The Black Mesa, located in the Panhandle, is the highest point in Oklahoma and one of the state's most remote and untouched regions. This area is rich in wildlife and ancient history, with petroglyphs and artifacts from Native American tribes found throughout the region. The Tallgrass Prairie Preserve, one of the last remnants, the once expansive tallgrass prairie ecosystem, is home to bison herds, coyotes, and a diverse range of bird species. This prairie offers a glimpse into what much of the American Midwest looked like before settlement. Could there still be hidden natural wonders waiting to be discovered in Oklahoma's Great Plains? Oklahoma's Native American heritage. Oklahoma's history is deeply intertwined with its Native American heritage. The state is home to 39 federally recognized tribes, many of whom were forcibly relocated to Oklahoma during the 19th century as part of the Trail of Tears, a tragic and significant event in American history. Today, these tribes not only survive, but thrive, preserving their rich cultural traditions, languages, and spiritual practices despite the hardships their ancestors endured. The Cherokee Nation and the Chickasaw Nation are among the most well-known, but many other tribes, such as the Osage, Seminole, and Comanche, have left an indelible mark on Oklahoma's cultural and natural history. These tribes maintain a deep connection to the land, which is reflected in their oral histories, sacred sites, and continued stewardship of Oklahoma's ecosystems. Collaborating with these indigenous communities is crucial to uncovering more about Oklahoma's hidden past. Their stories, knowledge of the land, and ancestral wisdom offer invaluable insights into the region's ancient landscapes, sacred sites, and ecosystems that modern science is only beginning to understand. Through partnerships with Native American nations, researchers and explorers have the opportunity to see Oklahoma through a new lens, one that respects the deep spiritual and historical ties these communities have to the land. From sacred mountains and rivers to ceremonial grounds hidden deep within forests, these collaborations could unlock Oklahoma's ancient mysteries in ways that honor both science and indigenous wisdom. How can modern exploration and indigenous knowledge work together to unlock Oklahoma's ancient mysteries? Future discoveries await. As technology advances, Oklahoma's unexplored regions will become more accessible. From drone mapping to satellite imagery revealing hidden valleys, caves, and ancient sites, the future of exploration holds exciting possibilities. Scientists are also beginning to uncover more about Oklahoma's prehistoric past, with new fossil discoveries shedding light on the ancient ecosystems and creatures that once. Oklahoma's vast wilderness is more than just a rugged frontier. It's a land rich with untold stories, hidden secrets, and ancient mysteries. From its red rock canyons and plains to its deep caves and forests, Oklahoma continues to captivate and inspire scientists, explorers, and adventurers alike. So stay curious and keep exploring, because who knows what incredible discoveries await in the hidden corners of Oklahoma. Before we wrap up, what part of Oklahoma's history, landscapes, or natural mysteries intrigues you the most? Drop your thoughts in the comments below. Thanks for watching. And don't forget to subscribe and hit that notification bell so you don't miss any of our future explorations.